Right now, our Earth moves around the Sun. It travels at an incredible speed, a silent journey through the vast emptiness of space. This path is not a random drift. It is a precise, repeating loop we call an orbit. The Sun, a star of immense mass, pulls on Earth with a constant force. We call this force gravity. At the same time, Earth's own momentum, its tendency to move forward in a straight line, pushes it outward. These two great forces, the inward pull and the forward motion, are locked in a delicate balance. This balance is the reason our world is not a frozen rock in the dark, nor a scorched cinder. This circular dance is the foundation of life as we know it. It gives us the reliable rhythm of day and night. As Earth spins on its axis, different parts of Earth receive more direct sunlight at different times of the year. The predictable change of seasons shapes ecosystems and agriculture. It dictates migrations, harvests, and the rhythms of civilization. The stability of our orbit is the quiet, unseen metronome for all of life. Like a ball on a string, gravity provides the inward pull. Momentum provides the speed. Our survival rests on a fortunate mix of mass, distance, and velocity, a narrow gift of stability. Now, let us imagine the unimaginable. Imagine that Earth's forward motion suddenly, completely stopped. For a moment, our planet would hang motionless, its orbital velocity gone. The outward inertia would vanish, but the Sun's gravity would remain. With nothing to counteract its pull, the invisible string would reel us in. Earth would begin to fall, directly toward the heart of the solar system. There would be no violent jolt. The surface would feel eerily normal at first. We, the atmosphere, and the oceans would all fall together at the same rate. Like a snapped cable elevator, you'd feel weightless, because all is falling as one. The first clues would come from the sky. The fall would start slow, then relentlessly accelerate. Gravity grows stronger with proximity. The pull would intensify. From Earth's current distance, the fall would take about 65 days, 2 months from stillness to a final fiery end. In the first days of the fall, the light would change. The sun would begin to grow in the sky. Daylight would shift from warm gold to stark, brilliant, clinical white. Shadows would sharpen, darken, and become more defined. The sky would lose its gentle blue as more intense light overwhelmed scattering. On the sunlit side, temperatures would begin a relentless climb. Within weeks, deserts would exceed any temperature we've recorded. Vegetation would desiccate into vast tinder, primed for fire. Planet-spanning wildfires would ignite. Even night would offer no relief. The ground would hold the heat. Oceans would buffer heat briefly, then their surfaces would warm alarmingly. Supercharged hurricanes would arise, fueled by overheated water. On the dark side, deep cold would grip a long, final night. A colossal temperature gradient would drive unimaginable winds. The world would be torn between fire and ice. About a month in, Earth crosses a critical threshold. Global temperatures rise until the oceans begin to boil. Not a gentle simmer, explosive, superheated water vapor. The air thickens into a hot, heavy, suffocating envelope. The world would be shrouded in a permanent fog of steam. Surface pressure would increase dramatically, crushing. A new water-thick atmosphere traps heat with ruthless efficiency. Trapped infrared radiation cooks the surface from every side. No rain, no clouds, no snow. The water cycle ceases. Life, from the smallest microbe to the largest whale, depends on liquid water. Boiling oceans trigger the greatest extinction imaginable. Any survivors are sterilized by a planetary autoclave. Complex organic molecules, the basis of life, are destroyed. Heated molecules and solar wind begin stripping the atmosphere into space, leaving a barren, airless, superheated rock. Gravitational chaos in the inner solar system. As Earth falls, the moon is dragged along in our planet's grip. But the sun's growing pull turns the system unstable. The moon's once stable orbit becomes erratic and unpredictable. It might be torn apart into a debris ring or stolen into its own orbit around the sun. Meanwhile, tides would become monstrous bulges of water, racing across continents. Planetary tsunamis would erase what remains, until the oceans are gone. Venus and Mars would feel subtle perturbations, tiny ripples in a finely tuned web. Over millions of years, small shifts could grow large. But during Earth's 65-day plunge, the rest of the planets continue their majestic dance, largely unaware. Near 60 days, the word heat no longer suffices. The surface reaches thousands of degrees, hot enough to melt rock. Granite and basalt lose integrity, flowing into a global magma ocean. The sun's tidal forces knead the entire world, heating it from within. The atmosphere ionizes into a glowing plasma. Day and night vanish into hellish light. Rock begins to vaporize, trailing a mineral comet tail behind the falling Earth. Crossing the sun's Roche limit, Earth is torn into molten fragments. The debris vaporizes on impact, its atoms absorbed into the star. From afar, only a fleeting flicker betrays the end of our world. This journey from order to chaos reveals how gravity, motion, and thermodynamics rule with quiet authority. Stability protects habitable planets. Orbital mechanics are a shield for life.